Differential Equations Assignment Help. For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. Problem 1a. Function f (x) is defined to be problems. For -2 pi less than or equal to x less than or equal to 2 pi, sketch the graph of y equals f (x). Do each of the following. I. Label all vertical asymptotes. Use the form y equals number. 2. Label all local maxima and local minima, if any. Give the coordinates for each labeled point. 3. Label all inflection points, if any. Give the coordinates and the derivative of each labeled point. 4. Label each region where the graph is concave up. Label each region where the graph is concave down. Mathsassignmenthelp.com. Problem 2. Figure 1 depicts two fixed rays L and M meeting at a fixed acute angle phi. A line segment of fixed length C is allowed to slide with one endpoint on line L and one endpoint on line M. Denote by the distance from the origin of ray L to the endpoint of the segment on line L. Denote by B the distance from the origin of ray M to the endpoint of the segment on line M. Denote by the angle made by the line segment and the ray L at the point where they meet. For the position of the line segment making B maximal, express A, B and theta in terms of the constants, C and phi. The expression for the one remaining angle of the triangle is easier than the expression for theta. You may want to start by computing that angle, and then solve for theta using that the sum of the interior angles of a triangle equals pi. Show your work. You may find the law of cosines useful. C2 equals a 2 plus B2 minus 2 of cos phi. Problem 3. Solve problem 17 from section 4.4, p. 137 of the textbook. You are free to use any valid method you like. You may find the following remarks useful. Warning: this graph is trickier than it seems. Before attempting the problem, it may be helpful to use a computer or graphing calculator to get an idea what the graph looks like. Figure 2 depicts an isosceles triangle circumscribed about a circle of radius r. The two similar sides each have length a plus b, and the third side has length 2a. Express the area of each right. Mathsassignmenthelp.com. A. B. B. R. 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 A. Figure 2, an isosceles triangle circumscribing a circle of radius r triangle in terms of either tan alpha or tan beta. Because the sum of the angles of A equals pi minus 2 alpha. Recall the double angle formula for tangents and the complementary angle formula for tangents. Tan pi minus theta equals minus tan theta. Using these, express tan beta, and thus the total area of the triangle, in terms of t equals tan alpha. Now minimize this expression with respect to t, find the corresponding angle alpha, and the height of the triangle. Mathsassignmenthelp.com. Solution A. Since y equals x plus x minus 1, then y equals 1 minus x minus 2. Therefore, we infer that there is a local maximum at x equals minus 1, where y equals minus 2, and a local minimum at x equals 1 where y equals 2. Considering that y equals f x almost equals x for large values of x, we are now ready to sketch its graph, which is shown in figure 1. Solution B. Let them intersect at the point x0, y0. Because they intersect at x0, y0. This implies that tan x0 equals 1, which in turn implies x0 equals pi slash 4 plus n pi for some integer n. Therefore, sin x0 equals cos x0 equals plus or minus 1 slash square root 2. Moreover, because the curves intersect at right angles. Mathsassignmenthelp.com. Solutions. In other words, a cos x0 minus a sin x0 equals minus 1 or cos x 0 sin x 0 equals plus or minus 1 slash square root 2 equals 1 slash a 2, hence a equals square root 2 since a greater than 0. Solution C. Which, when combined with the quotient rule, gives. We see that y equals 0 for minus 3 times 2 plus 3 is equal to 0. I.ex equals plus or minus 1. Noting that y equals 4 is a horizontal asymptote, which y gets arbitrarily close to as x plus or minus infinity, we form the table below mathsassignmenthelp.com. We're now ready to sketch the graph as in figure. Figure 2, the description of the wall and ladder as in problem D. mathsassignmenthelp.com. Solution D. The length of the ladder is given by then, we let equal to 0, which gives the equation for the critical angle theta, i.e. mathsassignmenthelp.com. Putting back into 1, we obtain. Solution E. The weight of the sheet of the metal is proportional to its area, which is A equals pi r2 plus 2 pi rh, where r is the radius of the base and h the height. We want to maximize the volume of the can. We express h from the 2, therefore by differentiating mathsassignmenthelp.com. Figure 3. A sketch of the circular pool in problem D. From which we obtain solution F. The time spent is differentiating and equating it to 0. mathsassignmenthelp.com. Hence theta equals pi slash 6 equals 300. Solution G. The length of the string is given by. Where x is the horizontal distance between the buoy and the kite. Differentiating with respect to time, we obtain. We observe that x equals 60 when L equals 100. Putting this and the given dx equals 20 feet per second in the last equation yields. Which is the speed of the string let out by the buoy. Solution H. We are given that the ice ball melts proportional to its area, in symbols. mathsassignmenthelp.com. Where V equals 4 pi r3 is the volume and A equals 4 pi r2 is the area of the ice ball with radius r. Rewriting the above equation and using the chain rule. We obtain therefore now, at half the volume the radius is given by the half volume is reached at t equals 2, therefore using 3, the radius r hits 0 at time mathsassignmenthelp.com. Therefore, the additional time necessary to melt is. Therefore, the additional time necessary to melt is 2 slash square root 32 minus 1 hours. Solution I. We are given y equals f, x, equals x3 plus 3x2 minus 6. Then, yj equals fj, x, equals 3x2 plus 6x equals 3x, x plus 2. We observe that fj, x, 0 only for minus 2x less than 0, otherwise fj, x, greater than or equal to 0. Some of its values are f, minus 2, equals minus 2, f, minus 1, equals minus 4. f, 0, equals minus 6, f, 1, equals minus 2, f, 2, equals 14. Now, since f, minus 2, 0, and fj, x, 0 for x minus 2, we can say that f has no roots for x minus 2. Also. Since f, minus 2, 0, and fj, x, 0 for minus 2x less than 0, we can say that f has no roots for minus 2x.